I like to sort of differentiate between junk and food. I think it's a fair point. They say junk food. It's not food, it's junk. And that's why they have to put all the fake flavorings in. But I don't want to go down that route. My background, as Jay said, I grew up on an organic farm. Had the privilege of my parents being leaders in the organic movement in New England. And my path to this broader conversation came through trying to make a living farming, which I'm not sure how many people here have struggled with. But growing up on an organic farm, and having parents who were leaders in that community, I didn't have the skills that I needed to be viable. And so I kind of came into this work that I'm doing through the back door, and that was, how do I make a living? And I was brought up with this concept that organic was better. We, at the farmers market, held our noses just a bit higher because they were chemical farmers and we were organic farmers. But when I got down to trying to make a living doing it, I started to think about the fact that the insects and the diseases were attacking my plants, but they weren't attacking the forests or the fields. And I thought if organic was better, being attacked by insects and disease is not a sign of health, right? If you're raising cows and they're being eaten alive by larvae, you probably think something's wrong. If you're raising chickens and they're being eaten alive by a flesh-eating fungus, you probably think something's wrong. But if you're raising tomatoes and you get, blight, it's just normal. If you're raising potatoes and you get Colorado potato beetles, it's normal. We've normalized these things. And so the first awareness that I engaged in this process was one of maybe I don't know as much as I think I do. And so I would, anyway, long story, started reading books, started going to conferences, started attending seminars, and practicing and learning. And have come in my own practice as a farmer to an understanding that only when the environment that a plant has evolved to live in is flourishing, will that plant flourish. And this gets to the point that I've been very passionate about, which is food quality and nutrition and nutritive value, and the term we've sort of helped popularize, nutrient density, because there's a direct connection between the environment that the plant grows in and whether you're growing a cucumber or you're growing a cow. That cow is hopefully eating grass, but even if it's not, the quality of the soil the corn is growing in has a direct effect on the health of the cow. So there's a really important point here, which is, as we understand from evolutionary biology, the microbes were here first, and they functionally evolved us, quote unquote, higher organisms, whether it's plants or animals, to reproduce them. And they're, the vast majority of the cells in our body, the vast majority of the cells in a plant's body are not plant cells, or in our body, they're not human cells, they're microbial cells. We are, at their whim and fancy. And so the foundational thing that I needed to understand was that I wasn't growing cucumbers or tomatoes. I was growing microbes. I was creating an environment where the microbes could flourish. And, for those who are in the agricultural space, I strongly recommend sort of the shift of perspective. There's only a few foundational things that a microbe needs. They need air to breathe, they need water to drink, they need food to eat. They themselves must be there. They need probably a few minerals to build their bodies out of. But in many cases, the way that we as farmers engage the land does not provide those environmental conditions. And so there's ways we can jack the plants up with fertilizers, we can kill the insects with insecticides, we can kill the fungus with the fungicides, and we can harvest a crop. We can harvest bushels of wheat or pounds of beef or whatever it is, but that material that's being harvested from that kind of an environment is foundationally different from what is harvested from an environment where the microbial community is flourishing. Mark said that you had a nice way of saying it about basically the nose and the tongue are the biggest book in the DNA chain, right? Our body, our DNA, has set aside a significant amount of its directions, its operating system for the subtleties of our nose and our tongue. Why is that? To the point about junk and food, when you eat a carrot from the grocery store and you take a bite into it and it tastes maybe like not much, maybe kind of woody, maybe a little bit soapy, maybe somewhat bitter, that's your extraordinarily sophisticated nutrient monitoring system telling you, as an animal, from an evolutionary perspective, this is no good for you. Right? We're taught to eat our fruits and vegetables. I would argue that in many cases, what we purchase on the shelf is much more junk than it is food. Of course, not Doritos or Snickers, but still relatively empty. When you pull a carrot out of the garden, or maybe at the farmer's market, you purchase a bunch of carrots and you bite into it, and you have that experience as an animal through your very sophisticated nutrient monitoring system of that flavor. That's a feedback loop telling you, this is good for you, do more of it. So this is the focus of our organization. As a farmer, growing up in an organic community, realizing that I didn't actually know much, studying, getting to a point where, without actually much effort or cost, pests no longer could eat my crops, diseases no longer could eat my crops, cost of production went down, economic viability went up. I said, boy, I've got a decent amount of experience here, and I've just come across a bunch of wisdom that nobody I know knows about, and I felt something of an obligation to begin sharing it. So I started giving workshops, and those turned into courses, and that turned into an organization. So for the past 10 years, I've been running the Bionutrient Food Association with a specific focus on what Jay said, increasing quality in the food supply. And by quality, we're talking about flavor, aroma, nutritive value, health-giving attribute. We think this correlates with soil health and plant health and human health, and perhaps, I think, actually cultural health, spiritual health, etc. I think from a foundational standpoint, if we are not vibrating in something resembling a coherent fashion, it's going to be very difficult for us to tune into our higher natures and to ground our higher natures in our day-to-day life. So from a strategic standpoint, it's my opinion that focusing on food quality can work to address a number of what appear to be intransigent existential crises. So let me just walk you through that in the short amount of time I have here tonight. The concept, as I said with a carrot, you eat one and you're like, meh, not so interested. You eat another one, you're like, ooh, I want to finish that one, maybe have another. What you're discerning is nutrient variation. There is a profound nutrient variation between this carrot and that carrot. There is no nutrient variation recorded or demonstrated on the bag of carrots, according to the USDA. Right? According to the USDA, every carrot is uniform. They all have the same amount of nutrients in them, as though it were number 2 plastic. Right? We have this conceptual framework of uniformity, which anybody who's got any experience with life understands is absolute bunk, but it's projected out there. And so, our thought is, if we can support people in making their purchasing decisions about food based on what's in it, its inherent nutritional value, and maybe some people here have come to the conclusion that money drives the world or has a very significant effect on what's done in the world. If we can make our purchasing decisions based on nutritive value, then we can begin to incentivize what might be considered to be solutions. It just so happens that the only way for those things called flavor and aroma to naturally get into a food, which are very long chain compounds, right? 10, 20, 50,000 elements in a compound. It takes a lot of biochemical work to build something that big. It's a symptom of a whole level of complexity in that food. Plants, through photosynthesis and soluble nitrate and soluble phosphate, don't have the resources to build those compounds. It takes too much work for them to build those compounds. They can't do it. And so they will build the body of a carrot, but they don't build the flavor of a carrot. The only way to get those compounds in a plant is when the microbes in the soil are doing most of the pre-building before those nutrients get into the plant. And so it's a really powerful dynamic whereby, I'm sure some people here are familiar with this concept, that plants have leaves that are green, and in the greenness in the leaf is this thing called chloroplast, and what happens in that is called photosynthesis, where carbon dioxide and sunlight and water are put together to make sugar and oxygen. The plants emit in nature that oxygen into the atmosphere, and they in nature emit that sugar into the soil. They don't, I like to say on the first 6 days, God did not invent fertilizer, right? For quite some time now, plants have been growing without anybody adding fertilizer. They evolved a very sophisticated, symbiotic ecosystem strategy with microbes. They inject the sugar into the soil. The microbes, there's the copper solubilizers and the phosphorus solubilizers and the potassium solubilizers and the nitrogen fixers. So they feed the sugar to the microbes. The microbes go out and they digest the environment and feed it back into the plant. The plant grows, it makes more sugar, it feeds the microbes more. You have this beautiful virtuous circle. So when you are eating something that has flavor in it, you're actually, as part of that process, facilitating this carbon sequestration process. People may have heard about regenerative ag and carbon sequestration and carbon in the atmosphere and those kinds of things. We were debating this morning or earlier today about actually how important carbon is in the atmosphere versus other gases, but that's a much longer conversation we don't have time for today. The point is, when you work with nature, things are healed. The broader ecosystem is brought more well together as opposed to, falling apart. So conceptually, if we can support people in focusing on purchasing food that's more nutritious, we can have systemically beneficial effects on the environment. That's the most important point I want to make. And then when we look at chronic illness, which most degenerative diseases, heart disease and cancer and diabetes and all these things, at their root are nutrient deficiencies. So there's direct correlation. What is it? Diabetes is chromium, right? I mean, it's been tracked out that these chronic illnesses that are becoming epidemic at their root have nutrient deficiencies as a causal factor. So we're literally just not getting into our bodies these nutrients. So disease on one side, environment, climate on the other. The point here is food quality, nutrient density is what I would like to propose as part of the future of food, is we focus on the actual foodness of the food. So our work as an organization is to focus on that effort, on that as a strategic objective. And so we, for the past 5 years, have been working on this project. One piece of the project is to identify the variation. So as of yet, there is no definition of what the optimal carrot is and the most rudimentary, the best piece of beef and the poorest from a nutritional standpoint, right? I think I'd read an article recently about a guy who was looking at garlic and trying to understand what's in garlic, what are all the compounds in garlic, and he went through the scientific literature, found about 2,000, maybe a little over 2,000 compounds that were recorded in the scientific literature as being components of garlic. And then he took the best cutting edge benchtop, equipment for assessment possible and looked to see what he could find. What's everything I can find? And it was over 10,000 compounds. 10,000 different compounds. We've got, amino acids and proteins and lipids and vitamins and enzymes and polyphenols and antioxidants and terpenoids and alkaloids and phenolics. And there's all kinds of fancy names for all these different things. But the point is, food is very complex. Right? It actually has a bunch of different things in it. And as of yet, no one has defined the variation. There is no scientific, database which says this is the potential of what a carrot could be. This is the least that a carrot could be. And so one piece of our project is to define that variation. We started in 2018 on that piece of it. We set up a lab in Ann Arbor. We sampled carrots and spinach from across the country. People went to the grocery stores, went to farmers markets, they went to farms, they got organic, they got not organic. And they sent in the carrots and the spinach to our lab, and we didn't have enough money, because we're a nonprofit, to assess all of the compounds. We only looked at like 15 different elements and a couple different compounds. But I just want to give some perspective on what we found. It was, and I use the examples of, calcium and iron. In carrots, calcium was 3 to 1. So this carrot had as much calcium in it as those 3 carrots. And in iron and spinach, it was this leaf of spinach has as much iron in it as those 18 leaves of spinach. So, if you're paying an extra 25% for 18 times as much, anybody who can do basic math might consider themselves to be getting a deal, if they were to be making decisions based on nutrition. But that's not the best of it. The best of it is those compounds that correlate with flavor and aroma. In this case, we had the money to look at antioxidants and polyphenols, which are sort of understood to be generally health-giving flavor compounds. And it was between 75 and 200 to 1. So this, polyphenols in carrots, this one had as many polyphenols as those 75. Antioxidants in spinach, this leaf had as much as those 200. So these are just examples of the variation of nutrient levels in food, right? It's absolutely stupendously large. In 2019, we added another lab, we added 4 more crops. In 2020, we added a third lab, and we added another 15 more crops. We found this variation across the board in all the crops we've looked at. We've looked at roots, we've looked at leaves, we've looked at fruits, we've looked at grains. We haven't looked at meat and dairy yet. But we found across the board massive variation in nutrient levels in food. So one leg of the stool is, what is the variation? The second leg of the stool is, how do you tell? How do you actually, in real world experience, go to the grocery store, go to the farmer's market, and see, of the 3 bags of carrots I have to choose from, which one's better? And my parents helped to write some of the first organic standards in the country, not the first, but early in the mid-'80s, organic standards. And I watched that system get, taken over by the government in 2000, and as far as I'm concerned, get weaker and weaker and weaker since then. I would say it's been co-opted by, economic interests. So my question is, how do we develop a standard for discernment that is, impenetrable to that type of energy? And so what we've done is we've developed effectively it's a handheld, it's called a spectrometer, and you put the leaf or the carrot or whatever it is right there, and you flash a light at it, and it spits out a number. So I'm not sure if anybody saw Star Trek. I think it was called a tricorder. The concept is that every element in chemistry is a vibration in physics. Every compound in chemistry is a vibration in physics. We can read what stars are made up of, not by going there and sampling them, but by taking a picture of the light that comes off of them. Right? Calcium vibrates at a certain frequency, copper vibrates at a certain frequency, helium vibrates at a certain frequency. So if you can take a picture of the vibration of the carrot, you can see what is and what is not in it. And while this is a rudimentary, unit, it does exist, it is calibrated. So step 2 is to get beyond the labeling and the marketing, to go straight to direct perception. So the farmer can flash a light at the leaf of the plant while it's growing and see relatively how well it's doing. The agronomist can make recommendations. The buyer can choose what premiums to pay on that bushel based on what was in the crops. The retailer can choose who to purchase from. The consumer can choose. The chef, the nutritionist. Our objective is to provide a framework whereby transparent assessment, empirical, honest assessment is a possibility. So I think that would be a way to get beyond the labeling and the marketing that I think have, in large part, sort of perverted this conversation. And the third leg of the stool is to correlate the environmental conditions and management practices to those nutrient variations. And so in 2019, we started working with about 35 farms in 2 of our, we had 2 labs, and we looked at the management practices, the fertility programs, the climate dynamics, the soil types, we basically document all those environmental conditions, and then we have the farmers send the soil in that the crops grew in, and then we assess the soil and the crops. And then in 2020, we worked with about 150 farms across both the US and Europe to sort of deepen that data set. And at this point, we can say, look, there's a direct connection between tillage and soil carbon and nutrient levels. There's a direct connection between, cover crops and biological activity and nutrient levels. We have direct, data sets that show how you manage the soil, how you manage the crop affects the dynamics of the soil and affects the nutrient levels in the plants. So it's a work in progress, but our concept is through empiricism, through transparency, through economic incentive, self-interest, for everybody involved, we can hopefully bring about a transformation of the way that food is engaged through. I'll just say in the final point, I'm not sure if I've used up my 20 minutes or not, I'm certain I probably have. We're an educational organization, we're a nonprofit. We're not violently, but dogmatically committed to all of this being open source. So right now, the plans for how to build this are online for free. Anybody can download them, can manufacture them, can sell them. The data sets are open. The app is open source. Our concept is that only through keeping this knowledge and wisdom and perspective in the commons can it be trusted, right? If it belongs to a company, if it gets proprietarily controlled, it can get turned sideways. So our hope is if we have this kernel of understanding and knowledge at the center, then many individuals will be empowered to make many billions of dollars off of this understanding. But that the core of it must be open. So I'll stop right there and thank you for your time. Thank you.